Well, you're all ready to start the problems, and I hope that you actually already did most of at least question number 1. And question number 1 is mainly about balancing. This is the method in which we balance in half reaction method. We split the two half reactions because they're easily split. Out of the half reaction method or oxidation number method, I think the half reaction method is easier and faster. So if you can split the reaction into two halves easily right away, do the half reaction method. Then balance all the elements which are not hydrogen and oxygen, balance the oxygen using water, hydrogen balance using H+, and then at the end, you balance the charge. How do you balance the charge? You use electrons. Once you have the half balanced reactions, you have to equalize the electrons and add, you get the full reaction, cancel any identical species. At the end, check. When you have a reaction in acidic medium, what we just did is we balanced in acid. But if you have it in basic medium, after you do the same thing that you did in acid, you add OH- to both sides, which are equal to the number of H+. And for the H+ plus OH-, that gives you one water molecule, and you eliminate the waters from both sides so that they are on one side, and at the end also check. So here we have the first reaction, and we have a bunch of equations. Okay, so the first reaction. Can I split it into two halves? Yes, I can. So a half reaction method would be the best. Of course, usually metals, it's easier to see. Always look for metals, split them, as well as the halogens. They usually undergo oxidation or reduction. So look for halogens and split them. Then we do the first part. Balance the atoms or the elements other than oxygen and hydrogen. I don't like the word. So there's nothing here to balance. The iron is the same, chlorine is the same. Balance the oxygen using water. Do I have any oxygens here? No, I don't. Do I have any here? Yes, I do. And I need 3 water molecules on my right-hand side to balance for the 3 oxygens on my left-hand side. Then I balance the elements of hydrogen using H+. So I have 6 hydrogens on my right-hand side. I need 6H+ on my left-hand side. And now we're ready to actually balance the charge using electrons. So I have to make something that's more positive, more negative, okay? 2+ on this side, I have 3+, and so I can add electrons to the product side so that overall we get a +2 charge on both sides. On this side, I have a -1 +6 here, and so that's +5 on my left-hand side. And on my right-hand side, I only have -1, and therefore I need 6 electrons because +5 plus 6 minuses become a -1. Well, you could clearly see that this is my half oxidation reaction because we lost electrons, or that the electrons on the product side, and this is my reduction half because my electrons have been added and they are on the reactant side, okay? Reduction, electrons as a reactant, okay? Great. Not that we need to know this at the moment. But in anywho, now what do? We balance what, I don't write that down here, just now we equilibrate the electrons on both sides. And to do that, I have to multiply this top by 6. And therefore, my electrons cancel, add the 2 equations, get a full equation, and you are done. Now for the same reaction, I'm going to do the same thing, but only the oxidation number method. Only to show you how it's done, but again, it doesn't have to be. Okay, so we have, first let's go with this one. Remember, oxygen always gets an oxidation number of 2 minus in majority of cases. So 2 minus times 3 is a 6 minus. and let this be x. X minus 6 equals minus 1. Take the 6 to the other side, you get plus 5 as the oxidation number of Cl minus. And remember, usually we use Roman numerals in order to distinguish that it's the oxidation number. I mean, I can just put plus 5 here, it's fine. On the other side, this is just an ion, and so the oxidation number is the charge of that ion. On this side, it's just an ion, the iron, so the charge is just the oxidation number of the iron, so plus 2, and here it's going to be plus 3. So now we have the oxidation number of every single compound or element in my, or ion, in my reaction, and then check and see, are we losing or gaining electrons? So for the iron, we have plus 2 going to plus 3, and so we have lost 1 electron, okay? So there's a plus 1. And then here, plus 5 became minus 1. So it's actually minus 6 is the difference. And so always take the product minus reactant, okay? Take product minus reactant, you get the amount. So what's happening? This is plus 1. In other words, here we have to gain 6 electrons to go from plus 5 to a minus 1. And here we lost 1 electron to become a plus 1. So that's just the number of electrons here lost and here gained. I mean, the minus and the plus don't show it, but that's how it is. And of course, what you should then automatically do is equilibrate the 2 electrons. And so we multiply the above reaction by 6 and then add the 2 equations, okay? That's how it's done officially. Clear? And then what you do is you balance. That means that all my electrons have been balanced. Then we balance the charge using H+. Now, some people actually sit there and balance the oxygen. No, the rule actually states to balance the charge first. And the reason is, you're going to see in a moment. Adding any water will not change my charge. So if I put H+ here for the charge, so let's look at the charge, minus 1, and here we have plus 12. So that's minus plus 11 on this side. And here we have minus 1. 6 times 3 is 18, so that's 19. Sorry, that's 17 on that side. And therefore, we have to have 6 H pluses on this side to balance it out. So 11 plus 6 will be 17. Notice here we added plus charge to balance the charge, okay? Because we already balanced the electrons. Now that gave me hydrogens, right? Yes, I didn't have hydrogens before. Now, at the end, we balanced both the oxygen and the hydrogen using water molecules. So add up these two. Look, on this side, I have 3 oxygens, I have 6 hydrogens, and therefore I need 3 water molecules to this side of the equation in order to get a fully balanced equation. Of course, you should always check at the end. Go ahead, check it. You will see that everything balances out, even the charges. That's the official way of doing it. Now, a lot of people, what they do is they do a half reaction method and an oxidation number method in combination with each other. And I'm going to show you that. Okay, let's, another reaction. Well, this is chromium, and chromium it can split, and that has iron, iron. Those can split easily into 2 half reactions. So we balance the atoms that are not oxygen or hydrogen. Iron here is balanced with iron here. Chromium here is balanced with chromium here. Done. We balance the oxygens with water. Great. We have, oh, just for a moment. 2 oxygens here, 3 oxygens on this side, and therefore I need 1 oxygen. And then we balance the hydrogens with H plus. But let's do the oxygens first using water. On this side, four oxygens, two oxygens here, so I need 2 water molecules. Now balance the hydrogens using H plus. You will need, oopsie, you will need 2 here hydrogens. You have 3 on this side, so we need 3 hydrogens. Of course, it's always easier to start with 1/2 and then go to the other completely. And then on this side, we have four hydrogens, and therefore that's 4H plus, okay? Then we balance the charges using electrons, so let's balance that. On this side, there's no charge, only a plus charge here, so I will add 1 electron to this side of the equation. And for this half reaction, I have 4 pluses and 2 minuses, which means it's 2 plus. And here there's a minus only, so what I need is 3 electrons on this side. And now we multiply by 3 on this equation to equilibrate the charge and add the 2 equations. You are done. Okay. Easy peasy. Okay, so the next question, manganese, sulfur. Okay, easily divides into 2 halves. Let's do the first half. Balance all the atoms other than oxygen and hydrogen. Notice, okay, they're balanced. So we balance the oxygens now. We have 4 oxygens and we have 2 oxygens. So we need 2 oxygens here. Then balance the hydrogens with H plus, and so here we need 4 H pluses, that will be fine. And then balance the charges using electrons. What charge do I have? A minus, 4 plus, so that is 3 plus on my left-hand side, 0 on my right-hand side, so I have to make the pluses more negative, or 0, so plus 3 on the left-hand side. Second half reaction, okay, there you go, that's it. Balance as well the elements that are not oxygen and hydrogen, well, they're balanced. Balance the oxygens, well, we have 3 here, we have 4, so we have 1 water molecule has to be added. Balance the hydrogens. Now the 2H is the hydrogen on this side, so we need 2H plus here. Now the charge, 2 minus on this side, and here we have 2 minus and 2 plus, 0 on this side, and therefore I have to add here in order to get 2 minus, because it's 0 on this side. I can't make the minus plus, I can make the 0 minus, okay? Now look at the electrons. I have 2 electrons here, 3 electrons on the other half reaction, and therefore I need a common or lowest common numerator, if you will, for both. And if you can't find one, then multiply the upper reaction by 2, which is equal to this number of electrons, and the lower reaction by 3, which is equal to this number of electrons. Don't forget to multiply everything. It's funny how you tend to forget. You multiply this 2 by these guys, but somehow you tend to forget to multiply them by one or the other of these. Okay, then you add and you are done. Of course, do a quick check and you should be okay. Next reaction, I surely can split it as well into half reactions. The Cl clearly will go with this Cl, the lead can go with this. But I think you all get a GIPS already of the half reaction method. So we're gonna use the oxidation number method now, just to, again, get you a little bit practice on that. Of course, we have an ion, and the ion will have an oxidation number equal to the charge. So here it's a -1. And for the lead oxide, for the chlorine on this side, we have oxygen, remember, that is a -2. And Cl will be my X, so X minus 2 equals -1. So for X, you get that +1, and therefore the oxidation number of chlorine is +1. On this compound, lead oxide, oxygen gave it to a -2, and the lead is X, so X minus 4 equals 0, and therefore this will be 4 plus. The lead on the other side, again, oxygen, you can actually take, anytime you see OH minus, take it totally as a -1. I'll tell you why, because oxygen is a -2, hydrogen is a +1, so the combination is a -1. I like to do that. So here we have a -1 times 3, that's a -3, and plus X for the lead equals -1. Solve for lead, you get it to be 2 plus. So what's happening? The lead is going from 4 to 2 plus, so it's gaining 2 electrons, or -2, gain of 2 electrons, and here we have going from minus to a plus 1, so minus to 0, that's 1, and 0 to 1, that's another electron. So here we have a loss of 2 electrons. So minus is reduction, oxidation is the plus. Okay. Again, products minus reactants. So put the oxidation number of the product minus the oxidation number of the reactant, you get it automatically. Look, +2 minus 4 minus 2. Okay, so that's a gain of electrons. Okay, so we have already the oxidation. Notice the number of electrons are balanced. So I don't have to multiply by any particular number or coefficient in order to to equilibrize the electrons. They're already equal, and therefore, you're done. Now, what do I have to do? Yes, watch out. We have to first, I don't have that written now, but first, what do we do? Balance the charge, not the oxygen, the charge. Yes. Because balancing the charge here, it's not like the other one where I get electrons where I don't have any atoms. Balancing charge here gives me hydrogen atoms. Okay, so it adds some hydrogen, it adds an atom. Okay, so -1 on this side plus 2 electrons. Okay, so, and yes, you have to consider the 2 electrons, or don't bother putting them in at all. Okay, and I would recommend that once you equilibrize them, don't bother to put the electrons into the equation. So I'm not going to really consider the electrons in because those are already balanced. So -1 on this side, -1 here. So plus 2 H pluses. Okay, so yeah, well, we did put them in here. So we get 2 H plus to balance the charge, and then you will need to balance the oxygen, and therefore you have 2 water molecules. Now, some people balance the oxygen and then balance the H plus. It works too, by the way. So you can give it a shot, okay? On the half reaction, the lead half, we put it all in. And so here we have only -2 charge, and on this side we have a -1, and therefore I'm going to add plus a hydrogen, single hydrogen, to get all this side to be a -1. And then look at the waters. I have 2 oxygens here, 3 oxygens here, so I need an extra water right on this side. Let's check if these hydrogens are balanced. I actually have 1 here and 2 hydrogens. Indeed, the hydrogens are also balanced. Add the 2 equations. Of course, the electrons already cancel, and we made sure that they do. And we're pretty much all done. Now, if I was asked that this is an acidic medium, I'm done. But if I'm asked to balance it in base, I just want to show you. It's not asked, but I want to show you. You add OH minus to both sides, and how many? You add the same number as H plus. So here I have 1 H plus, so I will add 1 OH minus to this side. And I also have to add it to both sides because it's already a balanced equation. Then add the full equations and cancel the waters at the same time. So H plus and OH minus gives you 1 water molecule. Cancel that immediately. you know, you don't have to write it twice. And here, add OH minus simply, and you would have taken away one water molecule immediately. Notice in my course, in each step, I wrote a separate reaction. That was because I was actually doing the course and I wanted you to see it step by step. Well, here I'm also showing you step by step, but you know, especially with the half reactions, I just write it one time. Try not to write it too many times because you don't want to waste the time. And sometimes when you're repeating the question, you lose an atom or something. Okay, one of the more difficult reactions is this one. The reason that it's a little bit harder is because I can't separate it immediately by heart. It's not just 4 compounds, it's more than 4 compounds. But when it's like that, first try to separate them, okay? How do we mean? Look at the copper on this side and the copper here. Okay, so clearly, I mean, they may have the same oxidation number, I'm not sure, but you know, I would definitely go for a copper on this side, copper on that side, though actually that copper doesn't even undergo oxidation. Here's a copper 2+, find the oxidation number here for this copper. It's also, the iodine is a -1. It will also be a 2+. So actually the copper is not undergoing a redox reaction, but nonetheless, it's part of the equation. So we're gonna keep it there. I'm gonna put a copper here, copper there. And then since I have iodine, what that automatically tells me is I need some other compound that has iodine. It's not something I can just add as I'm balancing. So I look for something on the product side that has iodine and I find this compound, so I include it also here. And then that put me some chlorine molecules. And so do I have something on this side that has chlorine? Yes, there is. And indeed, what's actually undergoing oxidation reduction here, it's not the copper, it's the Cl. But, you know, I'm not doing it in oxidation number method, but I am trying to split it into 2 separate halves. The other part is a little bit easier. We have selenium and another selenium on this side. And so, and we have, this is selenium sulfate. So clearly I need a sulfate ion with this half reaction. So that wasn't so bad to separate, okay? All right, so balance all the elements other than oxygen and hydrogen. So again, I'm not writing this down. Now we have to just do it. So we have copper is balanced with copper. Iodine, I have 2 here, so I have to multiply by 2. Chlorine is now 4, so I multiply the chlorine by 4. Okay. And on this side, selenium with selenium. Okay, that's already balanced. And well, let me just stick to one side first, sorry. The charge, because there's no oxygen, there's no hydrogen, so I'm pretty much done. I am now left with the charge, -4 on this side, +2 on this side, -2, so that's 0. And so actually I need 4 electrons. Here, okay, now the sulfurs. Sulfur with sulfur, that's done. And so, no, there's 3 sulfurs here, there's 1 sulfur there, so I have to have 3 here. Now let's look at the oxygens. And here, no, I have no more elements that need to be balanced. Now I have to go back and balance the oxygen with water. The 3 times 12 on this side for oxygen, and I have 3 and times 4 is also 12. Oh, they're already balanced. Great. So I don't have to add any water molecules. And now what do I have to do is balance hydrogens. There's no hydrogens because I didn't add any water molecules, and there wasn't to begin with. And therefore, I have to just balance the charge. I have 2 minus on this side, 2 plus, and -3 plus. And 3 times -2 is a -6, so -3 on this side, and therefore I need +1 electron to equilibrate the charge. Notice the two electrons on both sides are not the same. So what I have to do is multiply the bottom part by 4 to equilibrate the electrons. Of course, you can always tell who's the oxidation and who's the reduction by just looking at where the electrons is. Here, the electrons were lost, they're part of the product. Here, the electrons were gained, they're part of the reactants. Add now the two equations, and you're pretty much done. Okay, a little bit harder, but doable. All right. I'm actually going to stop here and